done so far? 5A, we started talking about statistics. Started talking about the population and getting a sample from the population, getting a sample statistic, being able to take that sample statistic, find your population parameter, and try to interpret what that means about our population. So 5A, we had the basics of statistics. We had sampling methods. We had, was it an experiment or was it an observational study? So we divided things into experiments and observational studies. And then like a subclass of like observational studies was what, case studies. So sometimes when you observe things, they kind of split themselves into variables and controls, right? That's typically what we want. We want like something that's variable and we want to have a control to kind of rule out other factors, right? Is the sort of approach that we take in science in general. So we did 5A, we did 5B last time. Were there any questions over 5A and 5B? And 5B was the 8 different methods of like determining whether something is a credible study. And so we talked a little bit about biases in that, considering the source, participation versus selection bias. We talked about those sorts of things in that section. Let's see. It's probably the better thing to look at. And 5A, we talked about single blind and double blind, what that means. Talked a little bit about margin of error, how to find that. Should we leave the study? So there were 8 criteria. Get a big picture view, consider the source, look for bias in a sample, look for problems in defining or measuring the variables of interest. So we want our things sort of well defined. Beware of confounding variables. So we talked about what a confounding variable is. Consider the setting and the wording in surveys. Check the results are presented fairly and stand back and consider the conclusions. What are the 8 different criteria? Trying to think of what I'm going to do, but I'm pretty sure I'm just going to give you, like, I don't expect you to memorize the 8 criteria by memory or anything like that. I'll probably give them to you, just like the brief description that's like on the quiz or something, maybe just to kind of help you along. You should know like kind of what they are. I feel like the examples in the quiz and the stuff that I'm giving you, it is pretty leading to which one of those things you should tell me. There's one thing you should definitely sort of tell me. If you want to give other reasoning, that's fine as well. There's probably other reasons that make the studies bad. But like problem 4, you're just critiquing studies on the quiz. And that was what, 5B. So 5C, we're going to talk about, we talked about frequency in 5C. Frequency, relative frequency, cumulative frequency. We talked about histograms, how to make histograms. We talked about how to make pie charts. The book, I don't like the book's definitions on qualitative and quantitative. I don't like the way they go about things in the book. But that's what we learned in 5C. And then 5D, they gave you graphs that were a little bit more advanced. They did stack plots. They did percentage changes. They did pictograms, things of that, infographics, contour maps. That was the other thing we had in that section.
I had a problem putting together your histogram for one of the questions. So I just put the gram together, but some of the definitions I had to handwrite.
For the histogram, for which one? In homework or in the quiz?
Homework.
Yeah, then on the quiz I didn't make you make it.
Yeah. So
I'm trying not to make you make too many graphs, because that's time.
I mean, it had us doing a whole bunch of graphs. I did a histogram.
Homework is nothing but graphs, and I looked at
it.
We'll try to get
I think this is what they call a bar graph. And then I did a pie chart. And then I did another pie graph. And so, yeah.
All right. So we'll start on the homework. And then I think, is that what you're asking, something over the homework?
Yeah, because I didn't do a histogram. The histogram was kind of hard to put the information in. I don't know why. The Excel thing, I guess I was putting it in wrong or something. So I just had to figure it out close to like I could and then do the rest by hand.
All right, so if it's in the homework, we'll get to eventually, hopefully. I want to make a frequency table for these grades. And so they want to do frequency, they want to do relative frequency, they want to do cumulative frequency. And so I want to make out a frequency table. So I have either A, B, C, D, or F. And then the last line, I should put my totals in. So the first thing that you could probably fill out is the totals. If we want to fill out the totals here, what's my total frequency here?
30.
30 students. So 30 would be the total frequency. The total relative frequency, what is that going to be?
100% or 1.
Yeah, that's the 100%. And then cumulative frequency, 30 again. So how do I find the frequency? What does that mean? America.
The amount of total A's, B's.
Yeah, so I got to count them up, right? So I think there's what, 6 A's? Is that what I'm saying? I count this up right? That looks off. I think I missed one. 6 and 6 is gonna be 12. Oh no, that's right. Okay, so we can add them up and see. I don't know how to add things in my head anymore, apparently. But there you go. Okay, so how are you going to find the relative frequency? So for A's, I'm going to take what? I'm going to take 6 and do what with it?
Divided by 30.
The percentage of the
Uh-huh. I was waiting for that. Total, right? Is what you're doing? 6 out of 30 should give you what? 20%, I think. We have to convert it to a percentage, maybe from a decimal to a percentage. 6 divided by 30 is going to give you 0.2. If that's 20%, and that's 6 of them, it's also 20%. If we do 10 out of 30, I got to round that a little bit. If I do 5 out of 30, that gives me what? 6. And if I do 3 out of 30, that's going to give me 10. And if I want to check and make sure I did these things right, what can I do? Add them up. Yeah, it should give you
100%.
100%. It might give you 99.9 if you rounded things wrong or something like that, right? But it should be pretty close. Cumulative frequency is the last one. I'll give you a hint. This one's 6. What's going to be my next one?
12.
12. And the next one is
22.
22. We're adding 10.
27.
5. 30. And then it should repeat for the last one. Are there any questions? This is something that should be completely doable. You should know like what each of these sorts of terms means. We've talked about, well, frequencies, I think is pretty straightforward from what frequency is, right? It's like how many times does this thing occur? Relative frequency, we've talked about relative difference, relative change. It's the same concept. We're comparing it to something. We have to divide by something. We have to divide by the total. Cumulative frequency, if you know what cumulative means, it means it's picking up one each time, right? We're going to add and add and add. Okay, if there's no questions, we will move on to 15. 17 and 21, we want to know whether these are qualitative and quantitative. And so if you watch the video, you might know I don't agree with the book on this. They did that weird scale, right? It was like a Likert scale or something like that. If you look at that, and we, like, from my understanding, like Likert scales get treated just like quantitative. I don't think they give us anything weird like that, right, on here. But rating systems, I would completely, if you're giving me a number, I would treat it quantitatively. I don't know why they said qualitative in the book. The reasoning was that it was subjective. And if you look at their definition says absolutely nothing about it being subjective or objective. So I don't think they define things properly in the book. So with that said, it was a bit of a rant, but.
So you're talking about the last question, I mean, the question that was in the book?
In the notes. Yeah, it's in the notes. It's like,
Yeah,
is it
in your video, you were telling us that,
on a scale of 1 to 5, how would you rate this, right? If you're doing a scale, like, that is totally quantitative. I don't know why they wouldn't make it quantitative.
well, yeah, because I thought, okay, so all of them I put qualitative, even the one that you said that was, they had the book said quantitative. And their description of the quantitative is really,
No,
I
they
don't
said
know how, I don't know how
I
you get that. I don't know how you get it, because you said measurements, they said quantitative was measurements.
And it was a measurement. It's a measurement of how much you like something.
No, it's something else. It's measurements in groups or something. Measurement in, it's something else, but it was, okay, so the qualitative, the quantitative, there was some other thing in there. There's two things in there. Hold on. Hold on. Oh, man. Where are you at? Oh, here you go. Okay, so they do the star from 1 star to 10. Okay, so I put quantitative.
Yeah.
They said it was
That's
qualitative.
absolutely what I would say on that. But for some reason, the book likes to say it's qualitative. I don't agree with the book, and I don't agree.
That was
I don't
kind of
agree that the
weird.
book defined things correctly for them to be able to say that. Like, what they're saying is incorrect with how they define things. And I would go with the definition. I would go with the definition that's in the book, right? And if you're giving me on something on a scale of 1 to 10, it is absolutely a measurement. Is it a subjective measurement or an objective measurement? No, it's subjective. But that's not within the definition. It doesn't say whether this is subjective or objective. And like doing higher statistics, we would absolutely treat that thing like it's a quantitative data. Like, I don't know like any instance where you would treat it qualitatively. And like, I even asked people about this, like, this is how much it bothered me. I was like, is that true?
Well, see, but the only thing I think that they
other
were
people
getting
were
at
saying,
was that the 1 star to 10 stars was counting. So
Yeah.
I don't know. I think that's the only thing I could see.
And the thing is, here's the thing: if you can put it in a scale, like 1, 2, 10,
Yeah, 1 to 10.
scale, you can take averages of it, right? If we can take average, and we can find people's average interest in something by looking at this average. It means something when you take an average, right?
Right.
It has a meaningful average that is quantitative. I would, by all means and metrics, treat that like it's a quantitative variable. I don't think they give us quite a weird examples
They
here.
don't give us enough information to do it like that. All they told
But these
us.
are numbers, right? These are numbers. These are measurements. I would treat that quantitatively. If it was categories, that's where I would treat it qualitatively. And you can have numerical categories. That's a thing that you can have, like social security numbers, bank card numbers, right? I would treat those things categorically.
Right.
It doesn't make sense to average your social security numbers, right? It's like, what is that doing? You're not going to put your social security numbers on a scale like this, right? Same with bank card numbers. You're not going to do this with the bank card number. You're not going to average a bank card number. That doesn't make any sense. Like, why would you do that? It's not a measurement, right? It's just like it's a class that you're in, right? It's giving me what your bank account is. So those would be like qualitative numerical variables. This is definitely quantitative when you can put it on a scale and do the average. The eye color of students in a class, is that qualitative or quantitative? So if we're talking about color.
Are you counting how many people have what color eyes?
So you're doing eye color like blue, brown?
Right, I know, but you're making a tally of how many people have blue eyes, how many people have green eyes, right?
So it's not saying the number of people with the eye color, it's just saying the eye color itself. If we're just
Yeah.
talking
Okay.
about the different eye colors, like blue, brown, green.
So it would be like they're putting them in categories, right?
You're putting them in a category, so that makes
And not so much as
If it's a category, it's which one?
Qualitative.
Qualitative. That's what I want y'all to get down. If you're putting it into categories, it's qualitative. If you can put it on a number line like this, and you can start making like histograms about it, right? Things like that, that is definitely quantitative. Qualitative, you're not going to be able to put on a number line. There's going to be a space between the bars. Here, we're not going to put any space between our bars, right? Home prices in a small town, would this be qualitative or quantitative?
Yeah, that's quantitative. That's quantitative.
definitely
It's not quality. That's quantitative because you're really counting.
And the last one,
prices.
annual salaries of NBA basketball players.
This one?
The annual salaries. Yeah, that's quantitative all day. Okay.
And I mentioned it in the notes, but if I give you a grade like A, B, C, D, is that qualitative or quantitative?
That's qualitative.
That would be
weird.
qualitative. If I actually give you yeah,
That's just weird.
right?
Yeah,
Because these are categories. If I ask you what the average of these things is, you wouldn't be able to tell me, right?
no.
'Cause you don't have the actual real number.
Right.
So that's a good.
That's
sort
a good one.
of- so these would definitely be categorical. If I gave you the actual percentage, it would be quantitative, right? Okay. 21, did I skip? I feel like I'm skipping something. This is like 21 to
No.
31. Nope. 25. Where to go? 25. Ooh. Out of order, but it's here. Here we go.
Yeah, we need to go there because this one I already did. This one I did. So we could-
Most populous countries, not counties. Following table gives the populations in the 5 most populous countries. Make a bar graph for these data with the bars in descending order. So these data are already in descending order. So a little bit, this is going to a little bit depend upon what sort of graph you're doing, or how big of a graph you're grabbing. This, I think there's around 20 tick marks here, and there's around 20 tick marks here. But we have to make a scale, right?
Okay, Professor. So I didn't do that kind of graph. The graph they gave me on the Excel on my computer was a bar. You know, like when you go to the Jesus, the home tab or the the insert tab, and you get the graph of the.
Mhm.
It comes up with bar, and then it has a list of all the different graphs. So, but their bar graph is different than what you're using right now. So,
Yeah, so you should be able to do these by hand.
okay.
So we want to make a bar graph. It sounds like you're using the computer. This
Yeah.
goes up to about, I would say that goes up to about 100. So I want to do 1400. I want to do it within tick marks. So if I want to know what my scale has to be, I'm going to do at least 1400 divided by 20. I'm going to do at least 70. I'm probably going to bump this up to do 100 each tick mark. So if I do 100 each tick mark, I'm starting off at 0.
Yeah, that's what the computer did. Did all of that. Yeah.
1400.
It went to 1600.
Yep.
Yeah, that's the computer did. I got the same graph, except for if the bar is going horizontal instead of vertical.
Yeah, I'd prefer doing them this way. So we
Okay.
want to do China, India, US, Indonesia, Brazil. I'm probably going to do them 2 wide. China. And I got to go up to 1400 about, right short of it. There's my China bar. Now I need 1267. So that's right short of what, 1300? So I want to make a little. Okay, so I know some of y'all do not have graphing paper. If you want, a good idea is to maybe print out graphing paper. Some of you don't have printers. So the next best thing is you're going to have to make a straight edge somehow. And these tick marks, they need to be sort of evenly spaced. So you can maybe make your own ruler. You know how to do that? If you have to, maybe make your own ruler. Just do two little tick marks, right? Make sure they're evenly spaced, right? Mark here, and then you go back up and make a mark. Somehow you want to make sure it's fairly even. And that we start at 0. So that was another thing that I talked about. We want to start at 0 down here, right? We don't want to start off on some higher number. We don't want to skip anything. We want to go up even intervals. Those are the things that are really kind of important on here. I guess typically there should. I wouldn't count off. Next thing is 300 is the US 321. A little bit past 300. There we go. US. Indonesia is 258, so I'm going up a little bit past 200 and halfway. And the last one is Brazil. And Brazil is right over 200. So our distribution should look something like this. Questions about this, about how to do this? Oh man, I didn't do this. We should really put some labels on there. The country, this is the population. So it needs an overall title, it needs a y-axis title, and it needs a x title. If this has units on it, this is population. This is probably pretty good if you just say population. If you're doing millions of people, you might have to tell me millions of people, something like that, right? But here we just did straight up population. I think we should be all right. Oh no, it's in millions. Sorry. Right there on the table. I should realize that. Population, the US has around 321 million people. I realized that after I was looking at the numbers. I was like, no, that's not right. It's got to be in millions. So definitely put your units on there. And if you wanted to say millions of people, that would also be a good thing to say. I guess the units is people. This is my population, this is my country. This is the population by country, something along those lines, right? Questions about this? How to do it? Well, this ain't a histogram, this is a bar chart. But how to do a bar chart? That's how we do a bar chart. I think the next one we're doing a time plot. So what's happening? Following table shows the number of cell phones in millions in the US for various years. Construct a time series graph for the data. Does the graph show straight line growth or linear growth, or is the growth faster than linear? So how are we going? We're going from 55, it looks like, up to 378. So I need to go up to probably 400. And if I got 20 tick marks, I'm going by what, 20s? So I probably need to space this by 20 each time. 20, 40 would be this one. This one would be like 80. This might be 120. So I'm going to go up 40 every 2, I think. Is another way to look at that. 140. I think I'm probably could have made it a little bit bigger than 20s, I think, maybe. 4, 8. Okay, does it say anything about D? Oh, never mind. It's not descending order. We're doing it over time. So we want to do it over time. 3, 4, 5. I think I got 10 of them. I think I'm going year by year on my y-axis. If I look along here, I'm probably going to start at 1597 here. 1997 here. 2000, 2001 here. 2003. 05. 07. 2015. Here we go. So I should probably represent, there's a little break in the graph or something, maybe. We're going 1997, 99, 2001, 2003, up to 2015. So how do I do this? How do I do a line? We did a line from a bar chart, but I don't know if I did a line just straight up like a line graph from this. So how would you plot this with a line or time series graph?
Make a point where the year and the data intersect.
Yeah, so you have 1997 and it's at 55. That's somewhere around here. So we're going to end up guesstimating these a little bit, right? It's not going to be precise. But at 97, I have 55. At 1999, I have 86. What, 100 in here? A little bit over 80 right here. This one's a 128, so this one's a little bit over 120. This one's at 159, so it's right there, probably right at 160 about. This one is 208, so I need to come up and do 208 is right at 200. 2007, it is at 255. 40, this one would be 2. The right shoulder of 260, right over 240. Somewhere in there. Whew, wrong point. Make sure they line up. Sorry, not that one. So with this, I think it's really beneficial to have some graph paper to do these graphs. A good way to get graph paper is just to Google free graph paper. You can print out graph paper if you have a printer. If not, you might have to start doing graphing. Find a straight line. Try to get a pretty good graph. 2009. About 2. I just put my points. 2011 is right at 316, which is pretty close to 220. Trying to keep it straight. 336 and 2013 is right over 320, 340, right in here. And 378 and 2015 is right about there. So I have this thing. This is called a scatter plot. If I put just the dots, it's called a scatter plot. If I want to do a line graph, watch it. Ooh, that's a line graph. I draw a line between each consecutive points. I go from a scatter plot to a line graph. And what does it say overall? What do you notice about the overall trend of this?
It's fairly linear.
It's fairly linear. Okay, that's what they ask. Does it show straight line growth? Yeah, it's fairly linear. And we're not going over correlation, but like a plot that looks something like this. Does that look like a line very much? This not so much, right? And so we're not going over like correlation or anything like that, but there's a whole sort of thing called regression analysis. And all that really means is like finding the line of best fit. Anytime you hear regression, they're just talking about finding a model that fits. So this we would be able to predict with the line fairly certainly. This less so, and this even less so, right? So they go sort of over that sort of thing. What does it mean to have things be correlated? And the later chapters, but okay, so now we're doing electricity use. Following table gives the percentage of electrical energy generated in the US from various sources. We're gonna have to display this as a bar graph in a pie chart. Then write a short paragraph discussing the pros and cons of each display. Okay, so I'm probably going to go from 0 to 100%. I think I got just enough. And so this represents what percentage? Total energy. This is what energy in the US. Something that's descriptive of what we're doing. The percentage of the total energy. And I kind of do my bar charts this direction, right? I think some people do them the other direction. I really prefer them to be this direction personally. I suppose you could probably reverse them, right? You could probably do energy source over here and percentage over here. Okay, so I want to do these. First thing I want to do is coal. Does it say in descending order? No, okay. The first thing I'm doing is coal. It's right at 33%. The next thing I'm doing is natural gas. It's at the same percentage. 33%. The next thing I'm doing is 20%. That's nuclear. Nuclear. Okay. Renewables, non-hydropower is what, 7%? A little bit over 5. Hopefully when I give you a graph, there's enough room so your words aren't running into each other. There we go. We are at what, 6% for hydropower, which is right under 5. And we're right below 5, right at 1%. Trying to get a little bit on here. This is at 1% for other. Okay. So now we need to make a pie chart. Same thing we want a title. So you want to put an overall title on this thing. So energy in the US. And I have a horribly drawn circle, but there it is. If I want to do coal, it's 33%. What's an easy way to do 33%? Do y'all know these ones? Maybe. What fraction is 33%?
A third.
Yeah, it's
Yeah,
about a third. So if we divide this thing into thirds, I think that's what we probably need to do. We divide our circle into thirds. We have what? Coal, 33%. Natural gas, which is also 33%. Both of those should be about a third. The next thing I see is nuclear power. That is 20%. So if I really wanted to crunch it, I could figure it out. I could do what? 20%. Multiply 0.2 by 360. Yeah, I can't see that. Which should give me 72 degrees, right? So if you wanted to do that, you could do that. But what am I probably going to look at? Like, what is a good sort of number? If I look at what, 25% of 360? I think that's probably the thing to think about, right? 25% of 360. What, 90 degrees? So if I quarter a circle, that's another way to think about it. I'm going to get that 90 degrees. So really, like, I know you're not going to have a compass and all that other good stuff on your test. It's not a compass that measures the angle. It's a protractor. Yeah. Protractor? Yeah, that's what it is. So you're probably not going to have all those weird tools on your test. But if you have to create a pie chart, like knowing that 25% is going to give you 90 degrees. So if we do 20%, a 90 degree would look something maybe like that. I want to go a little bit less than a 90 degree. So maybe like right there. That's about 20% in here. I don't know. And then I need to label this. I don't really have enough room, so I can always come out, and do a label pointing to it if you need to. That's going to be nuclear power at 20%. The other thing, 7%, so it should look like about half of this thing. 7%, and I got 6%, and I got 1%. All this 7% is renewable. This one right here is hydropower. So you should have an overall title. You should have a title for each piece of your pie, and you should have a number that correlates to that slice. I'm not, like I said, I'm not expecting these things to be exact, but they should be approximate, right? If it's under 20, it should definitely not be a right angle. It should be under a right angle. If it's over 25, it should be an obtuse angle, right? Questions about this, how to do a pie chart? Okay. So hopefully we can do a bar graph pie chart. And what do they want us to do here Following frequency table categorizes Nobel Prize winners in literature through 2016 by their age. At the time they received the award, display the data in a histogram and write a short paragraph explaining any noticeable trends. I don't like how they did this with under 50. I ranted and raved about this, and then now they're not going to do it. Your bins really should be the same size. They really shouldn't have done this. They should have said like 45 to 50 or something, right? But if you notice, your bins really should be the same size. They are all over here. So if we want to start, we have to go 50, 55. I think I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There's 10 of them. I think every 2 of them is what I'm going to have to go. If I want to go here, I think I'm going to start out at, I actually have to start out at 45, go to 50, go to 55, 60, 65, 70, 75, 80. Now I'm at 85 and like 90 here. And I think I went up. Yeah, that's what they were going to. 85 to 89. Okay. So this is the age. This is the what number of winners, and this is Nobel Prize by age. I'm going to change this just so we can say 45 to 49. It'll be easier to graph, and it will be more accurate with the way we should do things. It may not be accurate in reality to what the facts and figures are, but I'm going to make it easier. So if I want to do 45 to 49, that's this gap right here. So, oh, I haven't done my number winners. I'm going from 2. What's the most it goes up to? 20. I can go every 1. I can go every 2 probably. Let's just go by 2s. 1, then 4, 4, 6. So between what 45 and 50, I think I'm getting 9 winners. So I'm going to go up. There's my bar for 45 to 50. The next thing I'm looking at is from 50 to 54 is going to give me 10. I'm doing this one up to 10. The next one I have to go up to 18. The next one I have to go, it stays at 18. Next one goes up to 19. 65 to 69 is 19. 70 to 74 goes back to 18. 80 through 80, 75 through 79 goes to 15. 80 to 85 goes to 4. And the last one, I have 2 of them. And so for doing this histogram by bins of 5, what's the trend you notice? And remember, this one is scrunched up. It should probably really be spread out a little bit more, right? This last little bar should probably be a little bit shorter, a little bit more spread out, so to speak.
The younger you are, the less likely you are to be a Nobel Prize winner until you reach about 70 years old, 75 or something.
Yeah, so I would say that most of them are falling in this age range, right? From I think 65 to 70. So this is like where most of them are winning, is from this age, from like 50, I would say from 55 to 75, moreover in general, right? And then it starts like weaning off, right? Pretty quick. Most people don't live past this age, so same thing here, right? It should be the same sort of thing. It falls and it should continue falling sort of shortly, right? I'm not sure what the youngest person is that won Nobel. What was it? Oh, Malala, apparently, at age 17. So there you go. So there are some people way over here at age 17 that aren't even on our graph, right? And it would look like really short. It would probably pick up just a little bit each time, right? Until it gets up to here. And this one really shouldn't be as big because we shorten the gap. So with that said, I think the trend that they're wanting you to recognize is that most people are falling within this range, and then it kind of falls off this direction. It kind of falls off this direction. So most people are winning the Nobel Prize in their like 50s and 60s, right? Up to the 80s. And like it hopefully makes a little sense like why it weans off at the age of 80. They're not living this long, right? But I would say that most people are writing their Nobel Prize or doing their Nobel Prize work probably later in life, right? Is what it looks like. It looks like there's not so many young people. More like when you get into middle age, seems like when people are really starting to get their life's work recognized, probably, huh? Questions on that? Any input? Anything you see? Okay. Write a short paragraph. We didn't go over the section, but there's this thing, if it's the metric, we look for this sort of like bell-shaped curve, right? And we call this a normal distribution. So one of the things we might compare if we started going further in the book is, does this look like a normal distribution? It's a little lopsided over here, but that might also be because we've been categories together that weren't supposed to be. So it does kind of have that peak going in there, right? It does sort of have a peak. And for most sort of things that happen out there in the real world, you will notice those peaks sort of trying to happen. Most of it won't be exactly normal, but it will be pretty close. We can use the normal sort of curve to kind of get a handle on things. We like to compare everything sort of back to that normal curve in statistics. It's sort of like our unit that we use a lot of times. That was 5C. Are there any questions over 5C? Anything we did there that was like way out of the ballpark or anything? I think finding frequency, finding cumulative frequency, relative frequency, being able to do those histograms, being able to do those bar charts. That's what I'd probably really take away from that section. This one, I'm gonna have to do a screen share because there's just like a ton of graphs on this one. I don't want to I didn't want to have to copy and paste every single one of those graphs. We're going to look at graphs. And where am I going? 16. They want to look at this figure, so let me see if I can make it larger. Are the numbers going to get larger? Or are they just going to get blurrier? That's the question. What is the resolution here? Okay. Can y'all see that fairly well? Ah, stop it. No, don't go anymore. It's just like stuck zooming. Don't do that. What are you doing? Technology is fighting back. Am I in the right chapter still? How did I get
No,
6A?
you went to 6A.
What is happening? I will use boogers. All right, let's try this again. No, I want to go to 5D. That's where I want to go. Go to the exercises in 5D. We want to do exercise 15. I guess I could just go. This button is the one that gets rid of it. There you go. It was not that figure. It was this figure. All right, dare I push it one more time? Is that legible? Somewhat legible? This is the other thing. Like I figured like if I copied and pasted this and tried to print it out, that's like 2 or 3 different things that could just like blur it right there. And like I wanted to try to get some legible graphs on this thing. So 16 says, briefly describe how the unemployment rate has changed with time over the period shown over here. So we're looking at unemployment rate. How has it changed over time with the period shown? Has the trend in differences between educational attainment level remained consistent during this time? Explain. So what happened with the unemployment rate?
The less education you had, the more unemployment you see.
Yeah, so purple was the less education, not a high school graduate. This orange down here is a bachelor's degree. This is some college. This was high school graduate. So definitely with the more education you have, what they're trying to say is just overall. So not looking at the different colors, just looking at this overall trend, what sort of happened with the unemployment rate. So it looks like it's going down and up a little bit. So it looks like it's fluctuating a little bit here, just going kind of like up and down. But then here, I would say it jumps up around 2008, right? So we want to talk about sort of the defining features of this. So if you don't mention this jump around 2008, you're probably going to get some points off. This is a big sort of thing happening on this graph, right? You want to talk about it's going to jump up in 2008 and it's going to go down fairly quickly after that, back to normal, right? Do y'all see that, hopefully? Any questions on that or what would be expected? There's several things you could probably write that would be correct, right? But there's certain things you should really get down that you should really highlight. Key features, right? One of them being this jump. How has between educational attainment levels? So now we're looking at the gap between these things. Has it stayed constant? What would you say?
Yes.
It stayed fairly constant, right? I would say maybe it grew right here between not high school and high school. So people without a high school degree really got kind of screwed over on this one, right? Much more so than like these people. This one, it looks like a lot larger jump. So maybe that might be something to notice is like this jump is larger than these. And so right here, the gap is larger. Can y'all see my mouse when I do that?
Yes.
Okay, is my cursor? I'm hoping it's there. Okay. I'm enthusiastically using my mouse, so I was like hoping it was visible. Okay, any questions on that one? Has the trend difference been explained? For 2016, approximately how much more likely was a high school dropout to be unemployed than a worker with a bachelor's degree? So for 2016, I'm going along here to 2016. I can do some annotations on here too. Look at there. And I want to compare high school dropout to someone with a bachelor's degree. So this is my bachelor's degree. This is my high school dropout. If I'm looking at it, this is right over 8%. This is about right over 2, maybe 3. I feel like it's going from 3 to 9 is what you could probably say. Maybe from 3 to 8. Or from 2 to 8 maybe, or from 3 to 9. So what would you say? If you tell me 2 to 8, that would be what, 4 times as large? If you tell me what, 3 to 9, that's what, 3 times as large? So it should be somewhere between 3 times and 4 times as large, I think is what they're trying to get at there. Are there questions about that? And I know this is like you're trying to pull numbers off of a graph that aren't the most accurate, right? If you rounded this down to 2 and rounded this to 8, that would probably be fine. Or 3 and 9 might be good. Questions? 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 Are we getting this? Are we understanding this graph, hopefully? Do you think you could do this all on your own? Okay, stop annotating. How do I do that? Stop annotating. Get out of here. Can I move my thing now? I want to clear all my drawings. There we go. Now I want my mouse back, and I want to go to 513, and I want to answer number 19 is the next one. I want figure 5.13. It's 5.12. 5.13. So this is number 19. We want to look at this one. Number 19 asks, which cost category varies the least among the different types of colleges? Can you explain why this category varies so little? So which category looks like it remains mostly the same size? If you tell me dark blue, I'm going to cry. It's definitely not that dark blue. That is going up each time.
It's red.
The red looks like it's about consistent, right? It's going 1250 here, 1250, 1230. I think it's going from 1230 to 1390. I think that's the closest one in there. The green definitely changes quite a bit from here to here. The yellow definitely changes quite a bit from here to here. I think red is probably the most consistent. So red would be what? Books and supplies. So why would books and supplies be the same? So tuition's obviously going to cost you differently depending what college you go to. That's why that one's going to be so drastic, right? The room and board, that's also going to change depending where you live. If we're at a public university, like a 2-year public university versus a 4-year private, your room and board are going to be a lot more probably at the private university, right? Especially if you're living on campus. I think some of them say on campus. On campus costs more. Books and supplies, why would those be about the same? Because you're probably all buying it from the same bookstore, right? Probably all the same book. Transportation, why would transportation cost more on this one than it does on the others? I think it's because you're commuting here is what this says. And then other expenses, that's a very sort of vague sort of thing. I don't know. The other expenses don't change too much, right? I think they're going 22 to 21 to what? 21 to 16. So they are like less at this private one, probably. But we really don't know what other expenses are, so it's a bit hard to tell you why they are more or less, right? Any questions on that first part? Do you think you can interpret a stacked bar chart like this? Is basically what we're asking, right? Ignoring the other expenses category, the general trend is for all categories to cost more as you look down the chart, from 2-year public colleges to 4-year private colleges. However, one category is an exception in this trend. Which category, and can you explain why? So I think I just already answered that inadvertently. So this is all going up. This is going up. Which one is not going up?
Books.
Yeah, the books are going down, it looks like. I don't think that's the one they're getting at, though. I could be wrong.
Isn't it the other expense? Oh, they said ignoring the other expenses.
I think they're wanting to look at transportation, but I could be
Transportation.
wrong. Yeah, because transportation is pretty much, books are pretty much the same. It's going down a little bit, but it's not going down a whole lot. Transportation really goes down a whole lot from like this one to this one, but it stays the same. And I think they're wanting to highlight the fact that this is a public 2-year commuter, that you're commuting, so your transportation is going to be more here. I think that's what they're trying to get at with that question. Because I'm not sure I would be able to explain why books cost less. Unless your professor's writing them over here. I don't know. Okay, questions about this, about how to interpret this graph? This is what, number 19. 21 says we're looking at 5.14. Now we're looking at this stackable. And I don't know why I couldn't say tuberculosis, but it was just like, I had the word locust in my brain and it just like was not coming out of my tongue. I don't know if you watched that video, but it was horrible. I was pronouncing that word.
It was funny. I was like, you cannot say tuberculosis for nothing.
I could never in my life have I had a problem saying it until I started recording that video. So I don't know where it came from, but besides maybe having locust in the brain, but I don't know. What are they asking here? This is 21. For each of the 4 diseases individually, state whether its death rate increased, decreased, or remained nearly constant between 1900 and 1950. So we're just looking between 1900 and 1950. We're not even looking at like the whole right side of this graph. We're stopping right here. So what are the trends with the diseases? Did pneumonia go up or down?
Down.
It went down. So we're looking at the thickness here, right? So we're looking at the thickness right in here. So this is fairly thick. This is going almost 200 points. This is going maybe like 50 points in here. Pneumonia is going down. What about cardiovascular?
That went up.
That definitely went up. Yep. I think these are pretty realistic too. Like cardiovascular definitely went up. Probably all that sugar that they started promoting. Oh man. And then from here to here, I'm reminded of that stupid pyramid diagram that they always show. Like so it came from no one from a nutritional background had any input in that. That was like one of those purely political sort of things. You know what I'm talking about? The food diagram, the food pyramid.
Yeah.
Yeah. That probably contributed to this. They really underplay like sugar. Like you don't need any sugar, extra sugar in your diet. Like that's silly. But they put sweets on there, right? It's like you have to have sweets in it. No, you don't. No, you don't. You might want them, and I definitely eat my fair share, but you don't need them. That's just medical misinformation right there. I don't know how else to put it. But here we go. Tuberculosis to tuberculosis. Damn it. Did tuberculosis go up or down?
Down.
It went down. And then the last one, cancer, did it go up or down?
Up.
It went up. All those testings they did out in the ocean, probably, huh? Do y'all know? Are you familiar? Do y'all know they did like all those testings in like Bikini Atoll was the place where they did it? Are y'all familiar with that? Do y'all know what I'm talking about? All the nuclear
No,
testing they did.
explain.
Yeah, all the nuclear testing they did like underwater, they did it in this place called Bikini Atoll. So if you hear bikini, that word actually comes from the fact that like it was some French designer. He's like, I want my design to go over like a bomb. And it's like, so he named it after the place where they did the bombings. So if you look at the word bikini and its origin, it comes from actually Bikini Atoll. Bikini Atoll is a place. Bikini Bottom is where SpongeBob lives. I think they might be referencing that. But what is it? But bi doesn't mean two when you say bikini. But there are, what do they call them? Monokinis or whatever they call them. It was an after the fact sort of thing, but it's like the origin of the word, the bi in there doesn't actually mean two. So people are actually not conjugating that thing correctly when they say like monokini or something. Whatever they call them. Oh, odd little tidbit there. That, and then they use people as guinea pigs pretty much when they did that too. I don't know. It's not something that gets talked about a whole lot. But the Marshallese people, they like were totally downwind from like all that stuff that was happening. And they wait, we didn't answer all these problems. Sorry, getting on tangent, start talking about that thing. Yeah, so that's something that happened. About when did the death rate for cardiovascular disease reach its highest value between 1900 and 2015? And what was the value? So it looks like cardiovascular, where did it get fattest? It looks like right about in here. And if we look at from here to here, what would you say, 650 to 150? So if we subtract 650 from 150, what do we get? About 500? I want to say this looks about 150. This looks about 650. So I would say this thickness is about 500. So what does that mean? We're getting 500 deaths per 100,000 people from cardiovascular disease. And that was about 1960 was when it was at its height, is what it looks like. Are y'all seeing the same thing I am, hopefully?
Yes.
All right, so what was the approximate death rate due to cancer in 2000? So I'm looking over here at 2000, and I'm looking over here at cancer is the purple one. So about where am I at? This one should be fairly quick because we just got to subtract from 0.
Would it be
How
about
thick is-
100 or so?
I would say about 200 is what it looks like to me. Coming along here, it's about 200. You're doing 200 minus 0 would be what's down here, right? Or just do 200. Based on the trends in this graph, speculate on which of these 4 diseases will be responsible for the most deaths in 2050. Explain. Yeah, it's kind of tricky. Which one would we just say? I think there's one that kind of stands out maybe a little bit.
Heart disease? But it looks like cancer might be slowly on the rise.
Yeah, that's what I would say, because heart disease looks like it's on its way out a little bit. So I wouldn't say heart disease because it's shrinking throughout these last couple of years, right? So it looks like we're
Okay.
getting that under control. The thing that looks like it's really picking up here is those cancers, right? And they're going down maybe a little bit. I would probably say cancer. And like cardiovascular would totally be like a close second, right? You say pneumonia, I'm gonna laugh at you probably. You say tuberculosis, I'm definitely gonna laugh. Okay. Questions about that? I was laughing because it's like we got new diseases that we're going to talk about pretty soon here right now. They weren't planning that one. So 21, that was the one we just did. I want to jump to 39. I have the other ones printed out, so I'm jumping around a little bit. 39 says we want to look at figure 5.22. Which one is that? Oh man, I really love this picture right here. I like the one with the females better. It's pretty funny. 52122 is the next one. Here we go. So this is the changes in college tuition by actual tuition over here on the right, and then we have the change as a percentage over here. In what academic year did the public college tuition rise by the largest percentage? And what percentage was that? So they want to know, when did public rise by the most? I think I might have asked this in the notes. I try to change it around from what they give you. So where are we looking?
Skipping questions 23 and 27.
Yeah, I'm skipping around a little bit.
Okay.
What is it? 2003, 2004?
It looks like 0304 is the date, and what's that amount? I would say 13, probably.
Like 13%?
Yeah, 13% is good. So in 03 and 04, and it increased by about 13%. Private college tuition. So now we're looking at this one. We're going to 0304, and they want to know what percentage is this right here.
Do about 4 or 5.
Yeah, I would say, yeah, it's right around 4.5 or something like that, right? Like right in the middle of 3 and 6. So if you give me 4 or 5, that's probably right on. I think we're going to have to come along here, right? 0304. Yeesh, that's hard to see.
Is it private school?
It's hard to see on this one. I to be honest, like I can't even tell too well, because we'd have to look over here, and we'd have to look here. We'd have to look at, did this one go up more or did this one go up more? So if you can tell, you're doing better than I am, because it's hard to tell on that one. I guess we could take them out and try to figure it out. Yeah, it's not really easy to read on this one.
To me, it looks like the public went up like about 2,000 or so, and then the private went up, maybe about 3,000 or 4,000. Now that's just my guess.
Yeah, it does look like the private might actually be a little bit more, but it's really hard to tell on this. Like, that is not a good question. I would have made it a lot more sort of obvious if I was giving this.
Oh, I get it. So it says here in the year found in Part A, which had the largest increase in actual tuition in dollars, public or private?
But
Public.
part A was
So
asking.
now, can
Part
I?
A was asking for percentage, right? So we were looking over here at which one's taller. Now they want the actual like increase amount. So what we're looking at is like this gap right here. Like, is this larger, or would this gap right here be larger?
I think the 2000.
I think this one or the private 4-year is actually a little bit larger, but it's really hard to tell on this.
I would okay. So I was just gonna go with the 2007, 2008 because even though it's a small
This is
gradual,
this is smaller. It's got to be 03, 04 because the first question they ask is where is this the largest? And so
it's a
everything is
larger
hinging.
increase in total.
Everything is hinging on 03 and 04 after part A.
Okay, so yeah, the largest is 12%.
And then everything else references part A. So we're staying in this year.
Yeah, 2003, 2004. All right.
And we want to know the increase. We're looking at the increase from the previous year, right? I believe. Yeah, I don't really like that question. They don't give you a good enough graph to really look at it. I mean, I like the question. I don't like the graph they give. Is probably the better way to put it. Okay, that's 39. All right, I'm gonna have to come back and share this with 43 because that thing, I didn't get that thing down. But we will come back to 43. I think 23 is the one I skipped. 23 shows a stack plot of federal government spending categories as a percentage of the total spending with data through 2016. Part A says briefly explain how to interpret each wedge. What were the approximate percentages of the federal budget spent on Medicare in 1976 and in 2017? So how do you interpret each wedge? What are we looking at here? And it's not going to be any different from that previous wedge one. What do we look at to determine the size of this thing? Or how much you spent? So if we're looking at 1976, what am I to determine?
So we're looking at the thickness of it.
You're looking at the thickness or the width. So what would you say there? It's not the easiest thing to read. So if that's what's throwing you off, don't freak out too much. But how much would you guess that is?
30%.
Yeah, you would be careful. It is right at 30, right? But 30% would be from here all the way down. We're just doing this thickness. So we have to do top minus bottom.
Like 5%?
I would say like 5%.
Okay, can you explain that part?
Okay, so I'm going here. This thing maybe at
Your mic is out.
Yeah, you keep cutting in and out.
That's weird. I haven't got the they didn't give me my notice to tell me that yet. But sometimes it just does. Okay, so if I look along here, can you hear me now?
Yes, just fine.
Okay, so if I look along here, I will try to make sure I speak right into the computer. This is about 35 right in here. This is about 25 right in here. Is that what I'm saying? I think I'm probably going. That word is 35, 28. I would say maybe like 35 to 28, right? So this would give me about 7% if I did that.
Okay, I get it now.
So you have to look at the top, you have to look at the bottom. Also know a gap of this length is 10%, right? And so this looks about like half of a 10% gap, I think is what Anthony is probably looking at. And if I look at 2016, how much is being spent? So now I have to look along here. It looks like almost 40, almost 20. I would say probably about what, 20%? Now it's saying my internet connection's unstable, so who knows what's going to happen. Okay. I would say that's about 40 minus 20. Part B says in approximately what years was spending on national defense the greatest? So what are we looking at? If we look at national defense, that's like asking where it's what?
Where's the biggest was-
That did not come in at all. It sounded really staticky.
Hey, Professor, can I ask you a question, please?
Uh-huh.
All right, so and it's in regard to the Medicare question. When I did a ruler using a ruler, it goes right up under 30. It goes like 27 or 28. But when I do it with a ruler for the 2016, it goes just a little. It goes like in between 30 and 40.
The 35? Yep.
I'm
Yeah.
sorry.
It goes like close to, it's like 35. Yeah.
Huh? So that's about what, 7%, right?
Right.
That's what I got.
All right.
I said about 5 or 7%. You're in the right ballpark. Yeah, it's like not exact, right? We can't do this exactly. Like it's not an exact chart. Like I'm not expecting exact numbers on this, as long as it's pretty close. And approximately what years was spending on national defense the greatest as a percentage of the budget?
Would it be 1966?
It looks like it goes up right here. 869, somewhere in that ballpark. I would say somewhere between 67 and 69. After that, it starts slowing down. Somewhere right. As a percentage of the budget, how has spending for Social Security changed? So is it going up or going down, I guess is the question. How fast?
It's been a little inconsistent.
Pretty consistent.
Who's that? Is that Amanda? Like you're
I'm sorry. Yeah, my signal keeps going in and out.
Yeah, like I'm trying to hear what you're saying, but like it is just like really, really choppy. I'm just gonna give you a heads up on that one. I'm not trying to ignore you here, but I really can't hear what you're saying. If you wanted to try to log back out and log in, I'll keep an eye out for you if you wanted to do that. It might help fix it, but maybe not.
Okay, I'm gonna try that right now.
All right, good deal. As a percentage of the budget, how has it changed? I would say it went up slightly. It looks like it goes up slowly. It's about the same. But there's a small, like, sort of gradual increase throughout it, it looks like. It looks a little thicker throughout here than it does throughout here. I would say mainly Medicare was the one that looks like it went up the most, right? That one has a discernible, it definitely increased. Can you use this graph to draw any conclusions about how total government spending has changed with time? Why or why not? So can you use this to tell, I think the keywords here are total government spending, right? Does this tell us how much we spent in total on the budget? Do I know if I spent 1
Yes.
billion, 2 billion, 3
Yes,
billion?
it says you spent more on national defense.
So that would be relative, right?
Right, and you
That
like
wouldn't be the
lower-
total spending. That would be the relative spending. Like, how much did I spend on this versus this?
And then
When they say total spending, is there any way to tell whether I spent 1 billion or 2 billion or 3 billion or 4 billion or 20
No.
billion?
No.
That would be like the total spending. So there's really no way to get at total spending. We're just doing like comparing what our budget was spent on, right? We're not actually talking about the actual budget itself. We're just talking about the relative amounts. No, and I would say because we have percentages without a reference, right?
Okay, so I just thought they meant that, the national defense is lower, but other government spending was used in other parts instead of, interest on the debt or Medicare. There's growing more on Medicare, a little more on other, and a little more. If you can lift that back down, pull it down a little bit. Yeah, thank you. Other, and a little more in Social Security.
To be honest, I don't
I mean, if you look at from 66 to 2016, it looks like Social Security kind of wedged up a little bit. And then in other, it wedged up considerably. But in national defense, it went real low. And
I
then
could absolutely be wrong on this, but I think what they're talking about when they talk about total spending is they talk about the actual raw cash amount that we're spending, but I could be wrong. This is we're in 5D now, huh? We're in 5D. Let's see. 5D, this is what, number 23?
It says
What are
how
they?
total government spending has changed with time.
Yeah, that's what they're wanting. So when they talk about total spending, I was trying to make sure I was correct before I said this. But when they talk about total spending, they want to know like the money amount. And so with this, we don't actually know the money amount that we're spending. We just know how our budget is kind of partisaned up, right? Or how it's grouped up. But it doesn't tell us whether we're spending 1 billion, 2 billion, or 100 billion here, right? So I could actually be spending more money over here than I am over here. Not going to be the case, right? But actually, it will be with the national defense, right? We're spending more on the national defense now than we were back in 68. Huh?
No, we're spending more in 66.
No, go look at the raw amounts and what we're spending on the national defense. And I guarantee you in 2016, it's going to be a larger number than it was here. It's a larger percentage of the total budget, but this number is actually larger because our budget is larger, right? Like if I take 10% of 100 billion versus taking 50% of a million, right? This one's going to be larger over here than this one, probably. I would guess. So this doesn't actually tell you anything about the raw amount. It just tells you how it's partitioned up, right? It tells you relative how much we're spending on each thing. But it doesn't tell you the total amount. the raw dollar amount, right? We don't see that on here. We don't see that reference of what the percentage is referencing. If you have a percentage, remember when we talked about percentages, you have to have some sort of base number that you're referencing. It is a ratio. 27 to 28, we're doing this contour map. Shows the elevation with 6 points A through F marked on it. Assume that points A and B correspond to the mountain summit. Tip the top of the mountain. And the contour lines represent altitude changes of 40. So each time we cross a line, that's either going up or down 40. So if we're coming this way, I believe off the mountain, each one of those lines is going to be going down 40 feet. Use the figure to answer the following questions. Ooh, it's in Boulder. Boulder's a pretty little town if you've been there. If you walk from A to C, do you walk up or down? And explain how you know. I think I already went over that kind of, right?
Yeah, it'd be down. Because A is the highest elevation. Yeah, the summit.
Summit, yeah. If you're walking up from the summit, I don't know. I probably need to get your name or something and learn your magic. I don't know. Explain how you know A is summit. There you go. Does your elevation change more from B to D or from D to F? Or does it change more from here to here or from here to here? And how do you know?
B to D, because there's more elevation lines.
Yep. B to D, because more lines means there's more change. There's more elevation change. Questions about this? Are we getting this contour map? So this is like your plane is starting to go flat over here. They're getting really tight, which means it gets really tall really quick over here, right? So it's pretty graphic, and you can kind of see like the peak of the mountain. It's like if you're looking at a mountain from overhead, it might look something like this. Ooh. Oh man, I gotta have the graph stuff now. Moore's Law. Did we talk? Oh, that's the other class we talked about Moore's Law. Never mind. Moore's Law refers to predictions made in 1965 by Intel co-founder Gordon Moore. And it's been pretty true, I think, since he made it. But what he was suggesting is that the number of transistors in a computer would rise exponentially with time. I think he said the doubling time, but they don't have it on here, huh? It doubles about every 3 years. Is that what it is? Let's see. So I think he said it doubles every 2 or 3 years or something like that. Does anybody know off the top of their head? Are y'all familiar with this thing? Or is this the first time y'all heard it? Doubles every two years is what Moore said. The cost of computers is halved. And it's pretty much stayed that, but they're starting to reach like this sort of leveling out point here where it's not doubling quite as fast. And part of that is because you can only get atoms and electrons to be so small. Like we're making computers so small that actual physical constraints of the size of an atom and the size of an electron are coming into play and making it to where this isn't really true anymore. But they have things called quantum computers, right? And they're trying to get around those sorts of things. So this is something that is happening. It's something that's applicable, right? Construct a time series graph of these data and using a uniform scale on both axes. And then we want to construct one using an exponential scale with subdivisions of 1, 10, 100,000, and so on. Which of your two graphs is more useful for this data? So we want to construct it with Ooh. We gotta go up to what? This is thousands, millions, 7 billion. Okay, so I'm gonna go 1 and 20. So we're doing 10. I think every one of them has to be. 500 million? Yeesh. Yeah, 10 divided by a billion. Let's do billion. Yeah, because we have to do that. Okay, so every two of them, I think, is a billion. It's 1 billion, 2 billion, 3 billion, 4 billion, 5 billion, 6 billion, 7 billion. One, two, around 8 billion. And this is in billions. And this is transistors in billions. So maybe writing the right labels on your thing, like I emphasized, might be something I should do since I emphasized it. So those are transistors over there in billions. A scale that looks like 100,000 and so on. This one should be 100, and I wrote my words in the way, so now I'm going to have to write over them. 1, 10, 100. This one should be 1,000. So we're going by 10 each time. We're going to multiply by 10. We're going to add another 0 each time. So I didn't leave me enough room to do labels here apparently, but go. Do I have enough? $10 million. Am I going to get up to my 7 like I want? I don't think I left me enough room on this one. That's 100,000, and then this is 1 billion right here. I think I'll be all right until I get to my last point. My last point might be off my graph. All right, so we want to graph these things. We want to graph them with the normal scale. We want to graph them with a exponentiated scale over here. So if we try to graph this thing, and we're going from 71, 74. So why couldn't they just keep it consistent? 1971. I can't do it one by one. So what do I want my scale? I got to go a total of 2015 minus 1971 gives me 44. If I want to do that in 20. I think I'm going to have to go by 3 years for every single one of these. So let me reset this. 1971, this is 1974, 77, 1986. This would be 1989. So I think each of these goes up 6. So you want to make sure this scaling is consistent. So each of these represents 3 years. If I go up by 2, 6, so this is 1995 right in here. 2001, 2007. And on 13, 1925, 2019, 2025, 2031. I think I already went past my date, didn't I? 2015 is where I want to go. Okay. I'm going to go 1970. 77 right here. Hopefully I counted things correctly. 1989 right here. It looks like I did. Was it 1995 is the next one. 2001 is the next one. And I think I'm already up there at 2019 now. And so really this should be a 0. What there is there's actually a break in this graph, and maybe I should draw it, but we want to make sure we start out at 0 here. We want to make sure we go up by even intervals here. Same thing here, we're going up, but instead of even intervals, we're going up by powers of 10 each time. We're going 10, 100, 1,000, 10,000, 100,000, 1 million, 10 million, 100 million, and then we get to a billion. Okay, so now I want to plot these. 1971 is going to be around 2,000. These are in billions. So 2,000 is way the heck down here. It's way the heck down here. Until I get to what, a billion. I think they're all going to look like way down here. So I go 1971, I plot it. I go to 1974, I plot that. 1978 is right after 1977. It's somewhere down in here. You might notice all your numbers are under a billion until we get to like 2011. So they're going to be under a billion. There's going to be a $500 million. In 2003, I will get halfway there. 2003, 2004, 2000, somewhere right in here. 2011, I get to 1 billion, so I can actually put it over there in 2011, which falls somewhere right over here. And then 2015 is where I go up to 7. Right around in here, and I'm going to go up to 7. I don't want to spend a whole lot of time plotting this stuff, but I should you should be able to plot each of these points, right? They're not going to be very pretty on this because this is not the scale you should use on this thing. So if we look at something like this, and we didn't go over that section, but what does this sort of look like? If you have the math knowledge, maybe you know what it looks like. What sort of function does that look like? It's like we get a little bit of an increase, we get a little bit increase.
An exponential curve.
And then all of a sudden it skyrockets. So this really is starting to look like an exponential. Let's do that. Let's go. And what do I mean? An exponential is something where your variable is in the exponent. So if I get y equals 2 to the x, right? That would be exponential. Y equals 3 to the x. Means my variable is up in the exponent. And so what happens with things like this is they increase very, very slowly, and then all of a sudden they start skyrocketing. So things that increase exponentially, populations are one of the things that increase exponentially. Those two people have two people, and then those two people have two people. Each time you're multiplying by 2, right? Something like that. So populations tend to increase exponentially. Diseases tend to increase exponentially if they're communicable, right? So that's what kind of scares me when a disease goes around, because people do not know these things intuitively well, right? They definitely take some practice. There's an entire section and it has a bunch of fun little parables in it. And it is in the book. So if you want to go read those things, they are fun little parables. I can't remember what section it is, but it is the one where it starts introducing exponentials. And I can almost guarantee people get them wrong. That's how much people understand exponentials intuitively. It is something you got to look at for a minute. It is something that is fairly difficult. We tend to understand linear stuff really well, but this stuff, we tend to underestimate how much this thing's going to pick up, right? Is one of the things that we do. But if we want to graph this exponentially, what is this, 2,000? So 71 is around 2,000. It's a little bit over 1,000 on our exponential scale. The next one is 4,000, so it's a little bit above that. So 74 should be right there. Ooh, 71, 76 should be right there, sorry. The next one is 29,078. So somewhere in here, I want to go to 29,000, should be right over my 10,000. That point shouldn't be there. And that is around 78, around 82, which is right short of this thing. I want to go to 65. So that would be right about there, I think. Let's say 55. The next one is 200, which this is 100. It should be right over this. And that 275 is happening in 1985. I'm going to kind of guesstimate maybe somewhere in there. 89 is right here. I want to come up. 89 is going to give me 1 million right there. The next one is 93. 93 is like right in here. I wanted to go to 30. How is that? Okay. I feel like their number for 97 is wrong or something. Does anybody see what's happening? I thought it was going up and up, and now I'm just like looking
Oh, yeah.
Yeah, and then it just spikes back down.
It shouldn't do that. I don't know why it's doing that. And I think that's the way it is in the book. So it's probably a typo in the book. What problem is this? 37? Let's go see. 5D.
Yeah, that's the number in the book.
Why are they doing that? It should be going up. I think they meant to do like 37 maybe. It should not be going down. That's silly. 37 maybe? Let's just not plot that point. How about that? I don't think we're going to miss it too much. Let's pretend like we ain't even got this guy here. 93 around here. 2,000 is right around this line, and I'm going to 42. About the halfway point here. I'm going to 400. and 2003, which is right around here, and it's right around here. And 2011, I'm going to 1, and then 2019 is off my graph a little bit. So if you had to pick one of these graphs, one or the other, which one would you probably pick and why?
I would pick the
Second
first one.
Pick the which one?
Who said second one? You
The
go.
second one.
I said second.
I would definitely do the second. Why would you do the second?
Just because it's really hard to see the points on the first. You can't really tell what's happening except for the last one.
Yeah, I can't tell what's
Bunch of
happening until I
trillions.
get up to 1 billion, right? If I ask you any number left of this 1 billion, any number left of 2011, and I ask you to grab it from this graph, you're definitely not going to be able to do it. If I ask you to grab a number from this graph, you might be able to do it a little bit better, right? This one's still not that great, but it was hand drawn in what, a couple minutes. So if a computer did it, this one would be definitely easier to tell, right? And why is that? Why would we do a scale like this versus like this? What about this? Maybe it's kind of a weird question. We are over time. I didn't even realize that until just now. We're definitely over time. We got like what, 2 more problems or something like that, I think. So why are we picking a logarithmic, or not a logarithmic, a exponential scale here? And maybe it's kind of a weird question because we hadn't gone over exponentials. We're picking an exponential scale because this growth itself is exponential, right? Is what I was trying to get at. Does that make sense? If you pick an exponential scale for something that grows exponentially, it's typically might be easier to get your numbers off of there. And if we have an exponential scale and it's growing exponentially, this thing should look like a straight line, so to speak. It should be getting closer to a straight line, right? Okay, so I'm going to go back to 43. I'm going to have to do a share screen and figure out that graphic because it's a big graphic, but we can do it. What does 43 say? It's this graphic. I might have to like zoom out or something on this one. It's just a big graphic. Net, I almost said net gain. It's net grain, apparently. Don't lose your R. Net grain production is the difference between the amount of grain a country produces and the amount of grain its residents consume. It is positive if the country produces more than it consumes, and it's negative if the country consumes more than it produces. Figure 3.4 shows the net grain production of 4 countries in 1990 and projected for 2030. Which of the 4 countries had to import grain to meet consumptions in 1990? If we're looking at this, 1990s should be the blue. So which ones had to import?
Was it China, India, and Russia?
Yep, those 3. They are all negative. They are all in the negative. Seems like some American wrote this or something. It's like they're the US is the only one that's positive on here. Okay. And then 2030, the prediction, they're just like, oh, China's going to do horrible. But okay. Which of the 4 countries had to import grain? It was China, India, Russia. Which of the 4 countries are expected to import grain to meet consumption in 2030?
The same 3.
Guess what? It's the same 3 there. They are all 3 still negative. Given that India and China are the world's two most populous countries, what does this graph tell you about how world agriculture must change between now and 2030?
That's a big question.
Yeah.
It has to become more sustainable.
Yep. I would say that they're rising in population.
Yeah,
And so I think what they're predicting is they're taking like what their population is going to do, which their population is going to increase exponentially, right? So their grain production also needs to kind of increase along with their population, is what I think they're trying to get at with this one. So your agriculture also has to increase exponentially, ideally. But there's a lot of factors that come into play there too, right? I think there were like some predictions that we were going to starve or something. And it's like, they don't always account for innovation, right? Sometimes we get weird innovations that help us out, especially within food production. It's trying to predict nature there to some degree, right? It's like, it might be that. Any questions on this? There was one more I didn't do. I want to save this. I don't want to do this, but I want y'all to do this. Okay, so this for 49, 47, they say make a graphical display of the following data sets. Choose any type of display you feel is appropriate. Explain your choice and discuss any interesting features in the data. So in 49, they're giving us this table. They're giving us the year, and they're giving us the mean age in years. So there's probably really one way you want to plot this thing. Or there's one way I would think, probably. So I want you to plot this. How would you plot this, I guess is my question.
I'll probably do like a line graph, since it says that half of the population is below the median age and half is above.
Yeah,
That
the
would
line
be
graph would be perfect for this. So do a line graph for this. Why would you do a line graph? Because we want to see how it's changing over time. What do they call those time plots? Is that what it's called in the book? Is that what they call them? Yeah, I don't remember if that's the exact word. I believe they call them time plots. We're gonna plot this over time, right? I feel like I've done a few of those already. I did 2 of them, I think, right? 2 time plots. Does it seem fair to make y'all do one on your own? Hopefully. Okay, so I think that is it from the homework. If y'all want